going to work in Chapter 5. We're on the downhill slide at this point. This is one of the most important chapters that you guys have going forward, and you use these functions a lot in science. So just this one is really important. Don't kind of get a little slack on it because it's at the end. I wish we could teach it earlier, but we need some of those skills. So basically, we're going to explore two functions in this chapter, exponential functions, and then the inverse, which is the logarithm function. And so we'll start with the exponential functions. I do apologize for your note packet. I didn't realize that we had put so many exponential equations into this homework set, but we'll do several because they're not in the notes in 5.1 if you listen to those early videos. But that's okay. We'll cover them here. And there are videos, but it's in a different section, so I need to fix that. All right, so let's go ahead and start. These first ones, all you're really going to do is plug in. And so I just picked a couple off of this one. So we are looking at an exponential function here. H of x equals 5 to the x. And hopefully you did view the videos before. Exponential functions are functions that climb very fast. And so these first ones are just to plug some in. So if they say find h of 5, all they want you to do is 5 to the 5th power. And that gets big pretty fast. We can pull up our calculator. $31.25. And I picked a couple others just to remind you. So h of -1, you would just plug the -1 in, but I wanted to remind you what that means. It means move this to the denominator. So it's 1 over 5 to the positive 1. And you could plug it in and switch it to a decimal, should be 0.2. Also, I wanted to remind you, the last one that's there, anything to the 0 power is equal to 1. But you would get that if you plugged it in. From question 2, don't let this bother you too much. With a fraction for a base, we'll do just 1 on this, and then we'll put it in the calculator. You're still just going to evaluate. And so if we look at f of -3, this is 1 over 8 to the -3. So I'm going to show you just algebraically first to remind you the -3 would go to both the numerator and the denominator. So it would be 1 to the -3, 8 to the -3. You don't want a negative exponent, so you're going to switch places. And then the exponent becomes positive. And so you're going to work out 8 to the 3rd on your calculator. And you get 512. Hi, welcome Ryan and Charlie. Glad you guys are here. All right, so what I did want to mention to you on one of these is don't go through all this algebra. It's important to know that algebra, but do it on your calculator instead. And so, get my mouse here. So on the calculator for this problem, I would just go straight to, when you put that fraction in, put it in with parentheses. I do know that some of the TI-84 plus calculators have a fraction button, and if you do, you can use that. My TI-84 plus does not. If you have it, it is on this button, and I think raised over to the side, so you use a different color for it. Anyway, but anybody can put it in without a fraction button. Just use parentheses. So then 1 divided by 8, that's going to keep your whole fraction together. And then raise to a power. So if we were going to raise to the -3, there we go. We have the answer without all the algebra. So that is what I would recommend for these problems. Right. I did choose just one piece off of 3, and this is to remind you about order of operations when you are entering things in the calculator. Remember, the calculator is only as smart as the person pushing the buttons, so you have to remember to put things in correctly. So for this problem, and we'll just look at h of 1. You're going to plug the 1 into the v. Now, I know that you can do 1 plus 3 in your head and get 4, and that would be fine to do. I'm going to go ahead and not do that and do it on the calculator because you need to use parentheses if you're going to do that. Order of operations, we have to figure out this exponent before we do this multiplication. So your multiplication here is going to be last. So we want to use the E button, and it is above your divide. So you're going to do second and get your E. So you see E on the screen. We're going to raise it to a power, and because there's math to do there, we'll put it in parentheses. And later on in the section, you'll have some problems where you would want to do the math on the calculator. You wouldn't want to figure it out first. All right, so we'll put the 1 plus 3 in there. Close the parentheses, hit enter. Right, now do the times 5. And so it's just order was really what I wanted you to see there. So do this, put your exponent in parentheses for your calculator, then do the times 5, and we get 272.99. This says go to 4 decimal places, so you need to see 5 decimal places, right? And the 5 would push you up. So this is going to go to an 8, 272.9908. And I did pick one more off of there. I picked the -3, just to remind you. It also is order, really. So e to the -3 plus 3. And if you put it in your calculator like we did this one, it's going to work out. This is 0, right? The 0 only applies to the e. Anything to the 0 power is 1. Now that did not apply to the 5 though. So the answer to this is going to be 5 if you're working it out. So I just wanted that reminder. Let's enter it into the calculator since I still have it here. So first I would put in my e. So I have to do second and then divide to get the e. I'm going to raise to a power. I will put that in parentheses, even though we know -3 plus 3. Close the parentheses. Enter. This should give me 1 right here, right? And then you can do times your 5. There you go. Right, and then they do a bunch of graphs. So we'll get the calculator out of the way. And this may be a little hard to do on this screen because it doesn't show me as many of the graphs. This is a matching problem, and it is going to go through all your transformations, which we've already learned. What I would do first is I would pick out the one that gives me 4 to the x. This is your parent function, something to the x power, and that is our exponential function. All right, so we want the one that looks like that. We can graph it quick on the calculator. And this was 4 to the x. And so you'll see that this is a graph that climbs very fast, and the standard one goes through the point 0, 1. The horizontal asymptote on it is y equals 0. So let's look for that function, 4 to the x, in these. This one is not it. Right, this one looks close, but it's moved up. So this is going to be your +1. Looks like it's also moved to the left. This last one is the same picture as this one. So this is our parent function, which would be your first choice on there. So that last picture would be A. For these others, I'm not going to do a lot because this is a long section, but we'll just do 1 or 2, right, just to remember. And so the second one, if we're looking for it, it's going to take that function we had, and it has a -1 up with your x, so that is going to be a reflection. And when it's up with the x, remember that is a horizontal movement. So it is going to flip this picture across your y-axis and go the other way. And we can add it to our picture here. I'll just go down, so I'll leave that one on there, and I will put 4 to the -x and graph. And there you go. So this is the one. It's still going through that 0, 1, so you could look for it. Looks to me like this second one is that picture. Goes through this point. It's just flipped across here. So keep in mind to use your calculator for these, even though you should remember what some of these mean. We'll just talk about what they mean to remind us, right? On question C, right, this +1 is up with your x. Horizontal movement, remember it does the opposite. So this is going to go to the left. So it's back to that original parent function, but it's going to take it to the left 1. And so if we look, so our original, which we said this one is the parent function, it's going to go to the left 1. It's going to be this one. So next to the last picture there. This negative is out in front, and this is going to be a vertical movement. So this is going to flip it across your x-axis. So the picture will flip up and down, and normally it goes this way. Now it's going this way. I think it's probably that one. We'll scroll down and look. It's not that one. Mrs. H is wrong. Because the picture is going to look just like it did up here, except it's flipped across. It's going to be this one. And that's the same one I said. Okay. I don't want to spend too much time on these because you've learned transformations before. You can do them on your calculator and match them up and pick the right picture. This one over here, that is just a vertical movement of your parent function. So let's look at one thing on question 5, because question 5 gives us a fraction for the base. So let's see what that looks like on our calculator. And we're looking at all these choices. Again, we're going to match them up. And you want the one without the extra stuff on it. So your parent function on here is going to be f, right? It doesn't have extra pieces up here or out in front. And so 1/4 to the x is going to be this one. Let's go on the calculator. And we'll clear these out. And we'll use parentheses to get our whole fraction in there. 1 divided by 4. And we are going to the x power. And graph. Right, and so this is what it looks like. And just with the algebra, let's see if I can write a little bit here, and I'll pull the calculator back up. So this is on question 5. We're looking at the parent function. Right, this, remember, is the same as 4 to the negative x, right? And so this you could think of, this is our exponential function that looks like this. This negative up with the x makes it flip across and go this way. So I just wanted to point out that relationship. That is what putting this fraction in for a base does. And so f, pull our calculator back up. There you go. It's looking this way. And we can see which one this one is. Your very last choice there is moved up 1. Your horizontal asymptote is not 0. It is this first choice, right? Because that's going through 0, 1. So this is the parent function, and then you can look at the transformations of the others. So f would go on the first one. All right. For question 6, right, so you've seen these kind of questions before in the transformation section. So it's just doing it now to the exponential function. So we'll do 1 here. So we are doing g of x equals 4x plus 4 and a plus 2. So this one, to your exponential function, it is going to move it 4 to the left, and this will move it 2 up. So 4 left and 2 up. So 4 to the left. I don't like my pen. And 2 up. And then they want us to graph it. And they say use your parent function to graph it. Well, to use our parent function, and we're going to need 2 points to draw this graph. So let's pull, and you have your calculator. You could actually put that function in. So let's pull back up though, clear this one out, and just do 4 to the x. And so what you need off of here is your table to be able to draw it, or have done that by hand. And you want this point that would land here. So we want the 0, 1 as one of them. And then you can pick any other point. So 1, 4 is fine. And that looks like the best choice. So 1, 4. Now those are our parent functions. Let me go to table form. All right, and if you're doing it strictly with the transformations, this says subtract 4 from your x, and this says add 2 to your y of the parent function. So 0 minus 4 is negative 4, 1 minus 4 is negative 3, 1 plus 2 is 3, and 4 plus 2 is 6. So this would be the new function, the points to help you graph it, or you could have just put it in your calculator and pull that table, which we can also do. Let's go ahead and draw it. So, the other thing I wanted to show you here is it's going to make you put your horizontal asymptote on here. And on the calculator, remember we did asymptotes in that 4.5 chapter. Your asymptote on this parent function is going to be the x-axis, so it is y equals 0. If you're doing any vertical movement, that is going to change your horizontal asymptote because it moves your graph up and down, and that is what it always goes toward. So this one, your asymptote is going to be 2 because it's moved up 2, and that's the first thing you have to put on your graph. Let's go ahead and add that other one on here. So we'll leave the parent function. We'll add the other. You do need to use parentheses here if you put this in your calculator. So we're going to raise it to the power, put it in parentheses, x plus 4, close parentheses. If you have the TI-84, you need to go down there with a down arrow. And let's graph this one. So our first one will still be there. And so we're moved up and we're moved to the left. But you can see your asymptote has moved up too. All right, so that is what we have to put on first on the graph. And the directions here, I'm not sure I can get to all the directions without losing this. So it just says to go on that line and click any point on it. Just one click. Right, and that will put your asymptote on. It has to go on first. Then we'll click this button to draw the curve. Oh, okay, I should have clicked that first, I guess. All right, so now there's my asymptote. Now we'll put points And we want the ones from the new graph, okay? So we want negative 4, 3. We want the one that matches this that would have been the 0. Right, so negative 4 and up 3. And then we will do negative 3 and up 6. And there is our curve. And we'll check this one. We have some more questions to answer. I believe it says domain. And range. So domain is coming from negative infinity. It will keep going slightly to the right as it climbs. So domain is going to be negative infinity to positive infinity. And range, it will get close to that horizontal asymptote, but it's not going to cross it. So your lowest will be 2 with a parentheses, and it goes forever up. Right, and one more question. The equation of the horizontal asymptote is y equals 2. So we'll put those answers in just so we can see if I have the graph correct. All right, so equation here is y equals 2. This one is 2, comma, infinity. This one is in negative infinity, comma, positive infinity. All right. So we're good there. So several parts on that. So those you're used to. Just the graphing, when you hit your, I guess you have to hit your tool button first, but your horizontal asymptote is going to go on first. Any point on here, just click on that line, and then this is the point here, like right in the middle of your curve. That's the point you want to put on first, right? And then any other point when you put that. Any questions there? All right. So then I skipped down to 8. And I just pulled 8 because it is E. It has a base of E, so I thought we would do one, the base of E. And if you're not used to working with E, E is a value that is, it's like pi, it's an irrational number. So a decimal that goes on and on. And there you go, 2.718. So if you're looking at graphs, it is between 2 to the x and 3 to the x. So it's not quite as steep as 3 to the x. So we've looked a bunch at 4 to the x. So it's similar to that. It's just not as steep. Right. So your parent function here would be just e to the x. And your transformations We have a -3. It's with the x, so it's going to go the opposite way. So it's going to go 3 to the right. This is going to move it up. All right, so we can put those on. 3 to the right and 4 up. And so first let's go ahead and pull up our calculator. And we'll do y equals. And I'll put in plain e to the x first. Whoops. So there you go. And your horizontal asymptote here is y equals 0. We can figure out the horizontal asymptote before we even do it. This +4 is going to move the graph up 4. So our horizontal asymptote for this new picture is going to be y equals 4 is our horizontal asymptote. Right, let's go ahead and put the other. So the new function we want to do on here, which is e. Right, we're going to go ahead and do the exponent. Your x minus 3 has to go in parentheses because it has more than one piece there. And then we will do +4. So there it's moved up 4, and it has moved to the right 3 spaces. So this is your new one. We'll just keep that up because we just have to pick it out of these pictures this time. We don't have to draw it. And so this is our new one. It's not this choice because this one's moved to the left. This one has moved down, so that is not the correct choice. This one has moved down. All right, 4th choice. This one has to be it because it's the last picture. It has moved up, your 4, and it has moved this point, which was here, actually, which was here. It has moved it to the right, 4. So this is going to be your choice for your graph. Your domain is going to still be -infinity to +infinity. And we'll put that on there to make sure I pick the right graph. Then I can check the answers if I enter everything. My range, right? So your lowest point is going to be your horizontal asymptote. So it's going to be from 4 to infinity. Whoops. I was trying to go in the box. And this one, our equation of the asymptote, y equals 4. That should be everything. And that says we picked the correct graph. So don't be afraid of E. E is just, it's like a pi. And so it just is a decimal that goes on. And it's between 2 and 3. So it acts just like the other exponential ones. All right, I skipped 9. And I went on down to the equations. So a lot of algebra now. So we can get rid of our calculator. And these are the ones that I did not have in your video because I had them in a different section. They're not hard to do, but some of them you have to play with a little bit So we'll do quite a few of these. So we have 3 to the x equals 243. And so the way that you can solve these exponential equations, if you can get the bases the same, then you're allowed to set the exponents equal to each other, and that's how you solve. So get the bases to be the same. Right, so this one, it's a nice one to start with because it's 3 to a power and there's nothing else we could do to the 3. So we want to see 3 to what power is going to be equal to 243. So just get your calculator and play a little bit. And so we'll clear this out. So we'll just try things. So let's try 3 to the 4th, I think, is 81. All right, so we need to go higher. So 3 to the 5th, so these get big really fast, is 243. So we're going to rewrite this. Keep this side. This one we're changing to 3 to the 5th. Once the bases are equal, you're allowed to set the exponents equal. And then we're going to be done on this one because x equals 5. Sometimes you'll have some solving to do from there. But basically, that's your rule that you're going to use. Right? And we'll just look at the answer. So, question 11. We'll just get a new page. We have 27 to the x equals 81. Right. Now, if you try 27 even squared, it's going to be huge. So you're not going to be able to keep 27 as your base and make the bases match. Both of these have 9s in them, but even 9 squared gives you 81. So that's too big. So you have to go smaller. 9 is made out of 3 times 3. So these are both made out of 3 to a power. So let's rewrite 27. You might know that one. It's 3 to the 3rd. And 81, we punched this in a minute ago, it is actually 3 to the 4th. Right, so we have the bases the same. We need to just work this out. And when you have a power to a power, you keep the base and multiply those. So this is 3 to the 3x equals 3 to the 4th. Once these bases are the same, you're allowed to set the exponents equal. So our equation we're going to solve is 3x equals 4, and it's a linear equation. So you're going to divide by 3, so x equals 4/3. You guys stop me if you have a question. Uh, 12, we have to do work on it before we're allowed to work with that rule. You can't have all this other stuff on the left-hand side. So you want to isolate this piece to the power. So first you're going to take off your 34. So add your 34 to both sides. So you're still going to have this. Divide out the 6. $125. right? And now we're good. We want to try to rewrite 125 as 5 to a power, because that's the base we have here. And it is 5 to the third. So you just guess, you try 5 to different powers until you get that. So 5 to the x equals 5 to the third. And now you're allowed to bring these down and set them equal. And so it's actually solved at that point. But you have to isolate that piece first. Good. Now, for this one, we're going to do a little work on both pieces. We really don't want to work with a fraction to a base. So if you remember, to get something in that denominator, it's to the negative power. So 5 to the negative n is 1 over 5 to the positive n. And this would put the n with each one. So this is the same as 5 to the negative n. That would move it down. And this is the same as 1/5 to the n. So let's write it instead as 5 to the negative power. So remember, when you have a fraction, it's something to a negative power. Then we can rewrite 125 as 5 to a power. Now your bases are equal, so set your exponents equal. And this one will take one more step. You have to divide out your -1. So you should get n equals -3. Good. And I think this one also, if you get something you're stuck on, I think this first video is by Miss Allen, and it was a nice one, a nice short one. All right, so the first thing, I think, we're not going to be able to use 125 to a power. You can think of what that's made of, and there's a 5 in there. And so we want to see if 5 to a power gives us 625. And so we'll just play with that a little bit. So if we try 5 to the 4th, because 5 to the 3rd is 125. So 5 to the 4th, 625. Okay, so we're good there, except it's in the denominator. So that would just make us have a negative exponent. So 5 to the -4 is going to be 1 over 625, because that would be 1 over 5 to the +4, which is the 625. This would give us 5 to the 3rd, and then it's to the x, and your rule here is keep the base and multiply. So 5 to the 3x equals 5 to the -4. Now your bases match, so you can set these exponents equal to each other and solve. So 3x equals -4, and divide by 3. So x equals -4/3. So 15. And I'm doing a bunch of these just because You didn't have any examples in your other video. So 5 to the n plus 2 equals 5 to the 4n minus 6. This one, you're actually ready to use your rule right away because your bases match. So you set the exponents equal. And solve. This one is a linear equation. Your exponents are 1. So subtract your n. You could get rid of either n term. All right, I'm going to subtract this n. So I have 2 equals 3n minus 6. Add your 6. So 8 equals 3n. And divide by 3. So 8/3. Here we go. 16 we will do. We have 81 to the y minus 2 and 27 to the y minus 2. And so we have to rewrite these bases. If you remember, these are going to be 3 to a power. Break down to primes to see what they're made out of if you get stuck. We could look at 9. 9 is in both, but 9 to a power gets you high really fast. So 3. 3 to the 4th is 81. And 3 to the 3rd is 27. Now, on this one, what I wanted you to see, when you're ready to set them equal, but we'll clean up a little bit first, you have to keep the base and multiply the exponents. So you're going to have to distribute that 4 to both of those. So it will be to the 4y minus 8. And here, same thing here, keep the base and multiply. So because this is more than one term, it's going to have to distribute. So keep your base. This will be 3y minus 6. Now you're allowed to set these equal. So we have 4y minus 8 equals 3y minus 6. Then it's a piece of cake from there. Subtract your 3y. You guys could probably do that in your head. Leaves you a y minus 8 equals negative 6. Add your 8. And it gives us y equals 2. There you go. I'm going to skip this one, 17, just because I'm getting short on time and I want to keep time to do a couple word problems. Rewrite this as 10 to the negative 1 before you start, and then use parentheses here to work that out. So I will leave that at that. We do need to look at 18. It is different because it's going to give you a quadratic equation. So we have e to the 4x squared minus, sorry, getting a glare, minus 25 equals e to the negative 40x minus 20. So it looks more complicated. The base is already the same, so you are allowed to bring these down and set them equal. So 4x squared minus 48x minus 25 equals negative 40x minus 20. Notice when you get ready to solve here, exponent of 2, so it's a quadratic equation. Let's go to standard form. So we'll add your 40x. So we're going to have 4x squared. This will give us minus 8x. And we'll add 20. Give us a minus 5 equals 0. Now, you could try factoring. Remember, a lot of these don't factor. And so I would suggest quadratic formula here with a coefficient that is not 1 on that trinomial. So we'll use quadratic formula. So a equals 4, b equals negative 8, and c equals negative 5. And we'll try to scroll down to just work on that. So I'm going to just plug straight into the quadratic formula. So x is equal to negative b, so I need to put a positive 8, plus or minus the square root of b squared minus 4 times a times c. Whole thing is over 2 times a. Right, then we clean up. So we have 8 plus or minus square root 8, negative 8 squared is 64. This will give us plus, and we have 4 times 4 is 16 times 5 is 80 over 8. This gives us 8 plus or minus the square root of 144 over 8. 144 is a perfect square. It is 12. And then you just need to work this piece out. So do it with the plus. 8 plus 12 is 20 over 8, which you'll need to reduce. And common factor of 4. 4 go into 25 times. 4 go into 8 2 times. Use your calculator if you need to there. 8 minus 12 will be a negative 4 over 8, which gives a negative 1/2. So these are your answers. And there you go. So you might get a quadratic equation there. The next two, I'm just going to set them up for you. I'm not going to solve. So 19 we have 625 equals 5 to the negative 3x plus x squared. Right, so we need the bases the same. 5 to some power gives 625, and we've played with that one a little bit, so you can check it, but it will be 5 to the 4th. And then your exponents are equal. It is going to be a quadratic equation, so you'll get standard form. Move your 4 over. But that's your setup. I'll just put dots so you'll keep going. 20, I will also just help you set it up. So 5 to negative 5t squared minus 24t equals 1 over 3125. We need these as the same base. Okay, it's going to be a 5. So, and to get it in the denominator, it's going to be a negative exponent. So test some things. I believe it is 5 to the 5th. You can check on your calculator. Right, yes, 5 to the 5th is 3125. So if we do 5 to the negative 5 here, then we're going to be set. And we will just set those exponents equal, bring them down and solve. it will also be a quadratic equation. So we'll put dots there, and you can check that later. All right, I wanted to look at some of these word problems with you. These are not hard word problems. They are just using formulas that involve exponents. And the main thing is make sure that you're following order of operations when you work them out. So, compound interest, we're going to look at that. You do need to know what these pieces mean. And I'm just going to do the very first one on it, not all of them. So they're the same kind. Right, and this is our formula for compound interest. So accumulated, so this is the amount of money you have at the end. P is your principal, it's the money you're putting in. The 1 is a constant in the formula. R is your rate as a decimal. So drop your percent, go 2 places to the left. N is your compounding intervals, and the N is in 2 places. T is your time in years. So you are just going to plug in. So for our first question, we're looking for the accumulated amount. We are investing $43,000. So that is your P times 1 plus our rate, 11%, right? 11%. Drop your percent and go 2 places to the left. It goes in as 0.11. Divided by your compounding intervals. On this problem, it says compounded monthly. So there are 12 months in a year, so this is going to be 12 for N. Up here you have your N again, which is 12, the same as down there. And we are leaving it in for how long? 10 years. Right, so you're just plugging in to a formula. Let's do it on the calculator though. And I'm going to move the calculator right here. So, I would not use double parentheses. I would instead, you have to start inside, but I would enter that fraction first and then I would add the 1 rather than adding double parentheses in there. So I'm going to enter 0.11 divided by 12, enter. I'm going to add my 1, enter. All right, that's the answer to the parentheses. Okay. Now I'm going to raise it to the power. And this involves some math. You can do it in your head, but sometimes they'll get harder. So we'll go ahead and do it on the calculator. Use parentheses. So 12 times 10. Close your parentheses. Hit enter. Right. Now go back and multiply times your 43,000. And money problems, they usually want to go to the nearest cent. So your pennies place. So a 2 is not enough. This is going to drop off. And so we'll have 12,000, 8, 5, actually 128,000, 533. Okay, and we'll just look at the answer. But the whole thing there was knowing what the pieces stand for. Your percent has to go in as a decimal, and entering them in your calculator in the proper order and using parentheses where you should. So make sure that you practice that. Right, I want to try to fit in a couple more if we can. So we'll go down to one that is compounded continuously, and that will use an E, and it has a different formula. So 23 is compounded continuously, and it uses E. Has less pieces, really. All right, and so we'll just do the first one. So we're investing $15,000. That is going to be the P again. We're looking for the A. 15,000 times E to the R, right? You have 2.5%. You have to drop the percent and move your decimal 2 places to the left. So it's going in as 0.025. Right? It has to multiply by T. So 0.025, and I'll just use parentheses around it, times 18. So it's a matter of entering it in your calculator. So we'll first put the E, second, get our E on there. We're going to raise it to a power. Then you need parentheses because you're going to do some math. 0.025 times 18. Close your parentheses and go ahead and hit enter. Now do times your 15,000. And there you go. And to the nearest cent, which I suspect that's what they asked for, the 2 is going to drop off. And we can look. It is to the nearest cent. There we go. So it's really just plugging in and using your calculator correctly. Do a bunch so that you remember how to do that. All right, I'm going to try to fit in another one or two. Some that are not many problems, but really they are exactly the same kind of thing. So don't be afraid of these word problems. These are some of the nicest word problems because they're really just plug in. All right, and so unfortunately this problem, number 24, really is something that we are having to deal with right now in the real world. Inflation. All right, and so here is an inflation formula, and you can read the rest at your leisure. This is a future value. This is the present value, and they tell you what all these stand for. R is the inflation rate. You have to put it in as a decimal, and T is the time in years. So you're just going to plug in. So future value, present value, times 1 plus R to the T. And they are looking at a loaf of bread that's present value is $3.50. So we want to find what it will cost in the future. This is F. All right, so present value is $3.50. Your parentheses, 1 plus the inflation rate we're looking at, 1.47. Right, remember, drop your percent. Decimal goes 2 places to the left. So it is 0.0147. And then we're going to the T power, which is our time in years, 25 years from now. So then go to your calculator. We're going to work from the inside, so we're going to add this. We don't have a fraction in there to work out. All right, we're going to raise it to, whoops, bad Mrs. H. I need to delete that. I needed to enter that and get the answer to that. Right? Now we're going to raise it to a power, 25, enter, and then I'm going to multiply by 350. And this is money, so I am guessing they said to the nearest cent. which would be $5.04. That would be a nice inflation rate. There we go. And I think we have time for one more. And this one is a population one. Dr. Kilman wrote these problems. They're really cool because this one is for Vero Beach. And some of them come up with other local cities, so it's kind of cool. He looked up stuff that is relevant to us. So here is our expected population, right? So this model, it models the population of Vero Beach, where P is the population T years from now. And so all we have to do really is plug in and then know how to put it in our calculator. So not a hard thing to do. 4 years from now is the only one we'll do. So we'll do P of 4. And this is times 4. So we'll pull our calculator. And we're going to do our E first. Raise it to a power. You have math here, so put it in parentheses. And it doesn't matter where you put that 0 to the left of the decimal or not. Remember to close your parentheses. And I will go ahead and hit enter. Times your 16,410. Enter. And there we go. And this one I think said to the nearest whole number. And to the nearest whole number would be to the 1. So an 8 would push it up. So 19104. And there we go, expected population. So we'll stop there.